So next we'll talk about determinants and area. So if we have a 2 by 2 matrix, the area of the parallelogram determined by the columns of A is found by the absolute value of the determinant of A. Similarly, if A is a 3 by 3 matrix, the volume of the parallelepiped determined by the columns of A is found by the absolute value of the determinant. For example, here's a parallelogram with 4 vertices. So I want to find the area. First off, this is going to be a 2 by 2 matrix. So I don't need to consider all 4 of these vertices. I only need to consider 2 of them. So if you remember the parallelogram rule for addition, if I'm adding up 2 vectors, the other point of the parallelogram will be the sum of the 2 vectors. So I'm not going to use 0, 0 here, but you'll notice that 2 minus 1 is 1 and 5 minus 2 is 3. So the last vector here is the sum of the second and third. So I can ignore the last and only consider the second and the third. This gives me -4 minus -5. So this particular parallelogram has an area of 1. This one is slightly different since 0, 0 is not included here. So basically, this is a parallelogram in the plane, and we can just shift it so that one of the points is at 0, 0, and it will not change the size. It doesn't matter which point you pick. I'm going to pick the first one. Since I subtracted 1 from the first coordinate and subtracted 1 from the second coordinate to turn this into 0, 0, I should do that everywhere. So I get 6, -3, 3, 2, and 9, -1. Once again, you'll notice that the second plus the third is equal to the fourth, so I get to ignore the fourth. Taking this gives me 12 minus -9. So this one has an area of 21 square units. For the parallelepiped, we're given 3 points. So these 3 points completely determine the rest of them. And these are the 3 points that are adjacent to the origin. So basically the points that have a line from the origin to that point. Anytime if I ever ask you to find the volume of a parallelepiped, I'll only give you 3 points. So we'll just put them in a matrix and take the determinant. We should pick a row or a column to go down. I'm going to pick the first column since it has a 0. 1 times, if you delete the first row and first column, you're left with 2, 1, 4, 0. The second entry is a 0. The last one's a -2. Deleting those, I'm left with 1, 7, 2, 1. So this gives me 2 times 0, which is 0, minus 4 times 1. 1 times 1 minus 7 times 2. So -4 minus 2 times -13. -4 plus 26. So the area here is 22. And it's important to note that the volume here is 22. And it's important to notice that every time you calculate the area or the volume this way, you should end up with a positive number. If you do end up with a negative number, all you need to do is take the absolute value.